MLM's open-ended activities are strategically designed to engage and develop students' executive functioning. We propose that, when coupled with MLM's collaborative environment, lessons like the tortoise and the hare might help to improve students' inhibitory control, working memory, and cognitive flexibility. This video will provide you with some examples of how students are developing their executive functioning skills in the MLM environment. In a moment, we will begin our brief walkthrough of 4 students' collaboration while completing the tortoise and hare activity, where they were asked to recall Aesop's famous fable and engage with mathematical representations of the tale. On the specific slide, students are being asked to describe the movements of 3 animals, the tortoise, the hare, and the fox, based on the distance versus time graph to the left of the chat. They were then tasked with collaboratively creating a story of how the race might have unfolded. We picked this group because they showed a high level of collaboration and were mainly focusing on the executive functioning skills of 2 specific students, Olivia SD and Shania SD. Let's begin. Once the students establish that their task is to write a story describing how the fox ran the race, they begin their brainstorm. Olivia takes the lead, suggesting that all students write stories in the chat and that they will all choose one together. Building off of Chloe's proposal that the fox started late, Olivia offers that the fox may have won as well, referencing the graph as evidence. She says, quote, "I agree, but I think the fox won because its line is before the turtles." The group continues brainstorming. Shania proposes that the fox has taken a shortcut, and the rest of the group agrees. Olivia, who had been the group's leader thus far, asks the group if they all think that the fox won the race. Olivia then waits for each individual to agree before moving on, and prompts a Leomund for confirmation when they don't immediately respond. A Leomund suggests that, quote, "the turtle, fox, and the hare all met each other on the way to the finish line. However, the fox went a different way," demonstrating their mathematical understanding of the intersection point on the graph. Notice that all 4 group members have engaged in collaborative mathematical thinking up until this point. Olivia understood that the fox completed the race at the fastest rate. Shania rationalized the fox's quick finish by saying that it had taken a shortcut. A Leomund noted they all crossed paths after traveling 1,200 meters. And Chloe observed that the fox started late. Shania then begins discussing the race times of each animal, noting that the tortoise and the hare finished the race in about 12 minutes, while the fox did so in 10. Shania is also the first group member to acknowledge the distance axis of the graph, saying, quote, "we have to write the distance too." This suggestion leads the group to realize that all 3 animals went the same distance after Olivia says, quote, "wait, isn't the distance all the same?" This is an important mathematical moment for the group. Remember their previous shortcut idea? Well, after engaging with and interpreting the graph, the group has changed their perspective, with the now correct understanding that the fox finished the race first because it moved at the fastest rate. Satisfied with their understanding of the rates, distances, and times traveled by the 3 animals, the group moves on to finalize their story. Once again, Olivia checks in on each group member, actively seeking out their opinions and approval before moving forward. The group ultimately decides to combine a few of the narratives that they've begun constructing. Quote, "okay, we can say what you said, Leomund, but we need to add the time and distance difference." While this segment is brief, there is obviously no shortage of participation in the chat, collaboration on the activity, and rich mathematical thinking group members. Before going through this moment again to focus on specific examples of the students' executive functioning skills, it is important to note the distinction between traditional EFs, which are typically assessed to understand student attentional capacity at a specific point in time, and EFPs, or executive functions in practice, which describe extended EF engagement in classroom practices such as group work. You'll notice, however, that many EFP examples overlap, so that, for example, a student may be exercising both their inhibitory control and working memory while solving the same problem. The MLM environment provides a supportive and motivating context for EFs that make them relevant to the development of the student. EFPs highlight the relevance of developing EFs in order to work with tasks effectively. EFPs also allow consideration of the interaction of the different EFs over time. Now, with the EF versus EFP discussion out of the way, let's begin focusing on the moments in the session where we observe specific EFPs. The first EF we're going to focus on is inhibitory control. We can see 2 examples of inhibitory control in this moment. The first example focuses on response inhibition, which is when an individual suppresses their initial or natural impulse to do something in favor of doing something else that is more appropriate given their current task. Oftentimes, inhibitory control in the MLM environment takes the form of one group member suppressing their urge to do something they want to do for the sake of following previously established group norms and expectations. This group appears to have implicitly established the group norm of performing routine checks of understanding among all group members before advancing further into the problem. Olivia SD exercises their inhibitory control skills when, instead of rushing on to the next task and leaving behind their group members, as one may expect of a student of high math understanding like Olivia SD, they suppress the urge to do so and rather repeatedly check in with their group mates to make sure they are all in agreement about the story of the fox. The second inhibitory control example focuses on semantic inhibition and its relation to cognitive flexibility. Semantic inhibition refers to an individual's ability to suppress their initial or learned understanding of how to approach or solve a problem. The group begins the activity focused on the idea of shortcuts. They argue that the fox must have been faster because it took a shortcut. Eventually, Shania SD reminds the group that they need to incorporate distance into their final story of the race, which triggers Olivia SD to propose that the distances traveled by all three animals are in fact the same. Olivia's proposal then demonstrates semantic inhibition because it shows them resisting their and the group's initial explanation of a shortcut as evidence for the fox's first-place finish. The fact that semantic inhibition occurs might lead to asking why, or rather, what's enabling a shift from the shortcut explanation to one of distance equivalence and rate increase. This could be described as the kind of understanding that MLM supports. That is, both the pacing of working with the MLM online context that is shaped by the requirements of typing and turn-taking. This means that they focus on and work with a problem rather than being distracted by other students, as well as the fact that the environment is one in which the students are affirmed and feel valued. This kind of environment can relax participants, tell students that their ideas are valued and will be heard, and also makes them more willing to be able to pay attention to what others are doing and saying. The next EF we will focus on is working memory. Remember the Shania SD example from our discussion of semantic inhibition just moments earlier? Well, in this same moment, Shania is also engaging her working memory when she says, quote, "We have to write the distance too, because it says time and distance." The "it" here refers to the activity instructions the group first saw several minutes ago that prompted students to include specific details about time and distance in their final story. Thus, Shania SD's recollection of instructions that were brought forward and used in her working memory shifted the course of discussion in a meaningful way. It is also important to acknowledge the students' continued engagement throughout the activity. Their continued ability to maintain knowledge related to this problem can also be considered an example of working memory. The third and final EF is cognitive flexibility. Notice how, up until this moment, Olivia had been the one solely proposing texts for the group to submit. But with this chat, they propose that they each write stories and then collectively decide to pick one to submit. They generate preliminary text and ask for feedback from their peers, and they then revise this text upon feedback from Shania to include information about the animals' racing time. These interactions show that Olivia SD is cognitively flexible because they recognize the need for multiple perspectives to be shared and discussed before submitting a final answer, when they say we can choose, because they are able to anticipate that they may need to shift their own perspectives upon feedback when they say, "How is this?" and because they are able to accept their peers' new perspectives in their revision of their preliminary text. And finally here when they say, "The fox won by 2 minutes." Lastly, when Aliaman SD generates their own text, Olivia SD recognizes that their text may not be submitted as it had been in the previous problem, and proposes that they merge the two texts, as long as it includes Olivia's details about the time and Olivia's earlier suggestion that the distances traveled by the animals are the same. This is yet another example of cognitive flexibility, because Olivia recognizes that another approach is being suggested and accepts it. In this instance, we in fact see all three of the categories of EF working together. Cognitive flexibility, as just mentioned, but also inhibitory control, when Olivia SD asks their group to pitch their stories, instead of impulsively writing their own, and working memory, when Olivia SD reminds Aliaman SD that they need to add the time and distance difference. Thus, the MLM environment fosters the simultaneous engagement of all three EFs in this problem-solving context. At this point, it is clear that MLM engages students as EFs. MLM also encourages students to grow related skills in problem-solving and in collaboration. Collaboration, more specifically collaborative problem-solving, or CPS, is the second pillar of the MLM project. Collaboration is defined as supporting students' use of executive functions, and executive functions are supporting their collaborative work in mathematics. Collaboration takes on many forms in the MLM environment, one of which is the degree to which students build their ideas off one another. Notice how in this example, Olivia SD extends on Shania SD's thinking, thus further exploring the concept of distance. This group clearly demonstrates a developed understanding of teamwork, as they repeatedly complete checks of understanding with one another and come to a consensus before submitting their final answers and moving on to new content. The students are respectful and excited. They work together seamlessly as they make their way through this engaging activity. Collaboration and EFs combine to address the third pillar of the MLM environment, equity. Activities like the tortoise and hare are aimed at rehumanizing math education. Instead of having students complete traditional pen and paper worksheets, MLM activities such as this offer an alternative approach to mathematics that is dynamic, creative, collaborative, and student-driven. This activity in particular, with its engaging animation, dynamic graphic interface, and open-ended short answer prompts, encourages students to feel more connected to the math they are learning. They are no longer simply passive learners, but rather storytellers and authors in charge of their own math journeys.